Another example, problem 21. Here we have two cases. In the first case, we have this rope and also this mass which is hanging from this pulley. And in the other side, we are applying 40 pounds force to this rope. And this guy is gonna go up. And we wanna find the acceleration of this one in this case. In the second case, we are replacing this 40 pounds with a mass with the weight of 40 pounds. Probably some of you are gonna think they are the same, but you're gonna see they are not. And the reason behind it is the tension in the cable here is not equal to 40 pounds because this mass is gonna accelerate. The tension of the cable is not gonna be 40, it's gonna be less than that. So we need to find the acceleration in these two cases. Let's just start with this one. And let's say my coordinate is just x and y. And this one is gonna accelerate just in the vertical direction. Let's call it A, the acceleration. So sum of the forces in the y direction is gonna be equal to the mass times acceleration. So sum of the forces is, we need to draw the free body diagram of it. If you draw the free body diagram, we have weight, 60 pounds. And also we have two tension of the cable, and the tension of the cable is 40. So we have 2 times 40 here from the cable, so it's gonna be 80 pounds. So sum of the forces is gonna be 80 minus 60 pounds is equal to mass times acceleration. Mass is 60 divided by g, so 60 divided by 32.2 times A. One equation, one unknown, so we can find A from here, which is gonna be equal to 10.73 foot per second squared. This is in the first case. In the second case, the tension of the cable is unknown. It is not 40 pounds. And also the other point is, if the acceleration of this mass is A, upward, the other mass is gonna go down with the acceleration of 2A. Why? You should prove it yourself. I'm gonna let you do that part. And also we need to draw the free body diagram of these two masses separately. For the first one, we have 60 pounds downward gravitational force, and also 2 times the tension of the cable. But we don't know what is the tension of the cable. For this one, we have 40 pounds gravitational force and also the tension of the cable, T. And for this one, I'm gonna use XY coordinate again. This one is moving upward with the acceleration of A. This one is moving downward with the acceleration of 2A. Sum of the forces in the y direction is equal to mass of each one times acceleration of it. So for the first one, sum of the forces is going to be 2t minus 60 is equal to mass of it, which is 60 divided by 32.2 times acceleration, which is A. For this one, we have T minus 40 pounds is going to be equal to mass of it, which is 40 divided by gravitational acceleration, 32.2, times the acceleration of it. The acceleration of it is 2A downward. So in our coordinate, that's going to be a negative acceleration. So negative 2 times A. The rest is simple. We have two equations and two unknowns. The unknowns are T and A. So you can easily find both of these unknowns. A is going to be equal to 2.93 foot per second square. And tension of the cable is going to be 32.7 pounds.